we're going to do 3k squared. And I try to do different letters because we tend to always think they're going to be x's, and I'm bad about that too. And sometimes, you know, somebody says, when I make those x's, sometimes it is important, the variable may represent something. So you need to use the letter that's necessary, like D for distance, T for time. We use those a lot in application quadratic equations, that type thing. So sometimes you want to use a specific letter. V for velocity, that kind of gets you into some physics problems. Now, I will tell you that I'm going to today give you all, I guess you have 12 in classwork. I'm going to give you a leading coefficient that is not 1, but it is going to be a prime number. So I'm going to go ahead and put my parentheses, and the best I can do for these is kind of put you some little hints here, but I'm going to do it more by just talking about them. So why do we like the prime there for the first one? And this one's prime too. That makes it really nice. You know, the best are when they're both prime and when this is, and everything's positive. Those are the easiest when you don't have a 1 here. But why do we like that? Because 3k squared could only be 3k and k, right? You know, what's better, you know, we love k squared first. That's the easiest, k times k. But what's next best to that is a prime number. Because if you have a 12 here and a 20 here, you've got so many to choose here and so many to choose here, and then you just have to start guessing. So I try to stick mostly with, when we're using them in problems, I normally just give you a leading coefficient of 1. I want you to be able to factor it fast. But sometimes I have to give you these, and I usually, at this level, try to give you prime numbers. Now, do we know the signs? When everything's plus, we want to recognize that these are all going to be pluses. And it's especially important when this number is plus that your signs are going to be the same, whether they're going to be both positive or both negative. So when this is positive, signs will be same, and they're actually going to be the same as that sign right there, because positive times positive gives you a positive, and positive plus positive gives you a positive. Now, we love 5 because why? 5 is also prime, so what's your only choice of putting in the blanks? Okay, have you done any of 13 to kind of help you with that? It's got to be 1 and 5 or 5 and 1, right? See, here's where it gets a little different, because when you put 1 and 5 and K, it doesn't matter because they're both going to be 5K, 1K. But see, it's not going to be here. Putting the 5 over here makes this, well, let me back up just a little bit. I'm going to write the word full, and I'm going to tell you where you're going to, and I have to use that here, because when you have a prime number here, you will always know what your F's going to be. You know, if that is a 7, it's going to be 7 and 1. If that's an 11, it's going to be 11 and 1. If this is prime, we really like it. They're not all going to be prime, but in your classwork, they're not going to go above. I don't think you go any higher than maybe 18. I see an 18. I see a 36. But those are the biggest ones. Most of them run 10s and 15s and those kind of numbers, and a few of them are prime. And then, if you can get your factors of that one, that's your L. So we feel pretty comfortable right now that these multiply to that one, and these two multiply to that one. So really, the only thing you have to check are the O and the I every time. So what do? You start by just putting the numbers in. So I'm going to put the one that actually, because I want it not to work the first time, I'm going to put the 5 here and the 1 here. And I get 5K, and really I get 5, and I get 5K here, or just 5, and I get 3K here. Now, is there any way a 5 and 3 will give me a 6? No, so I switch and put the 1 here and the 5 here. It's either write it below it, mark them out. It's either, and I should have erased because I'm not big on people writing over numbers, so I should have erased that. This one should work because we only had 2 choices. And this one is 1K, and this one is 15K. And you see now why I don't have to check the F and L, because I already know those work. And I know that 1K plus 15K is 16K. So that is my factorization of that one. Also, I will tell you, none of the ones today will have a GCF other than 1. The GCF of this was 1, so we're not going to be looking at GCFs at all. everything today are factorable trinomials with prime number leading coefficient. The second rule that I'm going to give you doesn't apply to many of the examples today, and it actually just applies to one of them. And I don't know that it applies to much of your classwork, but it's one of those that you need to know because it really helps you. 2p squared minus 9p plus 42. Now, every rule I give you today is not guaranteed to work every time in terms of, now, signs, yes. This being prime, we can handle that because 2p squared has to be 2p and 1p. And I'm actually going to put the 1 on it if you need it. Do we know the signs? Now, in this case, we got a positive. So we got two numbers that are going to have to multiply to be positive 42. We'll address those numbers in just a second. And they've got to add to be a negative. So is there anything special about, and actually I'm going to draw, actually I need to draw it from this, draw it from the plus, and put that the signs will be the same as that sign. So in this case, they both would be negative. Now, do you see why? Because the only way I can get a positive for multiplication and a negative for addition is for both of those to be negative. So because this was negative, and that helps us a lot. Now, 42 is not prime, and I'm going to list them, and I want you to list all of them, and because I want to address some comments. 1 times 42, 2 times 21, again, in your notes, what you do in classwork may not be all of this, and then 3 times 14, and 6 times 7, is that the last one? I think that's it. Now, so I don't usually start with the off-the-wall one, like 1 and 42, or last year I didn't even put the 3 and 14 into it. I forgot to even write it in there. So, which is not good because sometimes you skip the one that works. So I'm going to go up here and I'm going to list them 6, 7, 7, 6. Now I want to address something here, and this is the only one that happens in your notes. And a lot of that is because this is prime, but it's even prime. And this is an even number. Now let's talk about GCFs. The GCF of this trinomial is 1 and will be in every one of your classworks. Now, if that is true, which we agree it is, then the GCF of each one of these has to also be 1. You cannot have a GCF over here other than 1 and have just a 1 over here. Now, I wrote it last block. I wrote no GCF in parentheses other than 1 in factors if GCF of original is 1. Because if I put the 6 right here, do you see what's going to happen? What will be the GCF of that binomial? It would be a 2, wouldn't it? But there's no way that if the GCF of this is 1, that you can have a GCF over here other than 1. Now, that's a little rule you may forget, but it's great, especially when this number is not a prime number. You know, if I've got a 4 here and a 42 here, then I want to check and make sure that like 2 and 21, I would not, if 2 and 21 was the answer, I could not put the 2 right there. If 3 and 14 is the answer, 14 can't go there because that would make this one have a GCF other than 1. So it's a handy rule. So I already know this one can't work. So let's try the 7 and 6. And if it doesn't work, then I'm going to have to go to my list and go to another one. And I probably would pick the 3 and 14. You just got to decide where you want to start. Now remember, you only have to check the O and the I. So this is negative 7. And this one is negative, now what have I done? And I've got negative 12. Oh, I've got this copied down wrong. That's a 19. That would make life a lot easier because I'm thinking this is not going to work. I think that one actually didn't work. And then I've got negative 12p here. And I'll really only just put the numbers. If you want to put the p's there, we can. And is negative 12 plus negative 7 negative 19? And that's the one that's the answer. Your goal is to hit the answer the first or second time. Will you always do it? No. Do I always do it? No. Number 3. 7x squared minus 20x plus 12. 7x squared has got to be 7x and x. Would I know what the signs are going to be? Minus, minus. And then we got to look at factors of 12. Now, most of these are in your factor trees, or in your multiplication tables. 1 times 12, 2 times 6, 3 times 4. Is that all of them? Yep. Again, the 1 and 12 don't happen a lot. 2 and 6, 3 and 4. I think last block I started with 3 and 4. I mean, I just pick one. I can't tell you that there's an easy way to start it. So if I put the 3 here and 4 here, I get, because the main thing is, are these right? Are the signs right? And do these multiply to 12? And then, so really you're only going to have to check this. Negative 3x and negative 28x, okay? I already know that won't work. And so then I'll reverse it and do 4 and 3. And I got negative 12, negative 21. That one won't work. And sometimes you can do those in your head, especially when the signs are the same. So let's go to 2 and 6. And I've got, see, because GCF across the board here is 1. So I don't have to worry about that. 2, because if one of these was even, that would knock this set out completely. Negative 2 and negative 42. No. 6 and 2. And that's negative 6 and negative 14. Is that it? And negative 14. And let me write that a little bit better. Let's see, this was my 6 and this was my 2. Okay. Trial and error. 3r to the second plus 11r minus 20. Now the last 3, we're going to do 4, 5, and 6, are going to be negative at the end because these are the toughest ones. Why? Well, let's get our L first. Let's get our 3r and our r. And what happens when this is negative? Okay, one of them's got to be, signs are different. One of them negative, I'll just put different. One positive, one negative. And I don't put them up here yet. We did yesterday, we did Monday, but that was because both of these were r's. You're not guaranteed if I put negative here, the positive here, that that's the way it's going to go. This is the one you really have got to watch the O and I when you do it. 20 is kind of messy. I can still write it up there. 1 times 20, 2 times 10, 4 times 5. Is that it? Okay. Now, 2 and 10 and 4 and 5 are both in your multiplication tables, but for some reason 4 and 5 kind of jumps out to me, and I'm going to try it first. So I'm going to put 4 and 5. Notice I'm not putting any signs on it. When this is negative, I do not put signs. But when this is negative, you have to think subtraction. So when I do this, I've got a 4r and a 15r. Now, can I relate 15r and 4r to 11 because this is negative? I can. Now, on your paper, write 4r, 15r twice. Make this positive, this negative, this negative, this positive. Write it that way on your paper. This one will give you negative 11. This one gives you positive 11. So it is the 4 has to be the negative one. And here's another way to look at it. It was this product, so it had to be that one. And then the 15, which is these two, has to be the positive. Because, see, it's not going to be the 5 and the 4. It's going to be their products. So, again, we're only looking at the O and the I. We already know that the F is right, and we know all of these multiply to 20. So we've got that part.